Hello everyone, welcome to the Knight class. I'm Coach Knight, and today's lesson 4.5, we're going to talk about graphing systems of inequalities. If you saw my last video, 4.4, we graphed a singular inequality. It had two variables, but it was just one, so today we're doing a system of inequalities, which basically means we're just graphing two inequalities at the same time. So let's get busy. Here we go. First example, we have y is greater than x minus 2 and y is less than or equal to negative x plus 1. So we take them one at a time. We're going to start with the top one here. So its y-intercept is at negative 2, where it crosses the y-axis, and its slope is positive 1. So we're going to go up 1 over 1, up 1 over 1. That was a bad spot. There we go. Up 1 over 1, and as you can see the pattern going. And since it was just a greater than, so this will just be a dashed line going this direction. And we will shade, let's see here, what can I go yellow? We will shade above this, so we'll shade everything above it. I'm using a highlighter so we can see our shades are going to cross here in a minute, and we want to be able to see where they cross. So that would be the top equation. So the bottom one starts at positive 1, and it has a negative 1 for its slope, so that means go down 1, right 1, down 1, right 1, down 1, right 1. It is a less than or equal to, so it will be a solid line. And we will graph that, and then we will shade it. Let's see here, let's go blue. We will shade, it's less than, so we will shade everything below this line. And as you can tell, hopefully you remember from science class or middle school or elementary or wherever you talked about your colors, art class I guess, yellow and blue make green. And so the green shade would be your answer to this system of inequalities. So it's where their shades cross each other. So everywhere where you see in green, that is the solution. All right, let's try another one. So same thing here. We're going to start, the top one starts at 2, and it goes down 1, right 1. Our slope is negative 1 again, so we're going down 1, right 1, down 1, right 1 for a while. It is greater than or equal to, so that's going to be a solid line. And we will shade above because it is greater than. So let me shade as fast as I can here. Like I said, the highlighter shades a little quicker than just a regular line. So there we go. All right, you get the point. And then for our next one, we're going to cross at negative 2. It has the same slope, which means our lines are parallel. So, since our lines are parallel, that one should have been a little further down. Since our lines are parallel, this is a dotted line. The lines will not actually ever cross. And it looks like we are going to be shading this one. It's less than, so it's shading down. And so just like when you when you graph systems of equations and their lines don't cross, if their shades don't cross, your answer is no solution, because the solution is where the shades, where the graphs intersect. And since there is no intersection of the graph shades, the answer to this is no solution. All right. Example 2, going the other direction this time. They give us the inequalities and we have to make the system. We have to write out the system. So the best thing to do here, they have a red line and a blue line. We'll do the blue line first. I'll put it in blue so you can know which one we're talking about. For the blue line, you need to know its slope and you need to know its y-intercept. So The y-intercept's easiest. It's right there. We're crossing at 4. The slope looks like it's going down 1, left 1. So, and it's going down from left to right. So that means the slope is -1. And I already put an equals here, but I don't need to put an equals. I need to put, let's see here, it is shaded above the blue line. So that is a greater than and equal to, and then -x plus 4. That is the blue line's equation. So now let's do the red line's equation. The red line, as you can tell, it's a dashed line. So that means it's just going to be just less than or just greater than. And since everything is shaded below the red line, that means it's going to be less than. It's crossing the x or the y-intercept at 3. So b is 3, and its slope, let's see here, it goes up 1, 2, right 1. So 2 over 1 is 2. So 2x plus 3. And that is your system of equations, just like that. Our next examples are very similar. We'll do these real quick. So again, the red one, we need our slope and we need our y-intercept. So the y-intercept looks like we're counting by 2's here. So the y-intercept is 2. The slope would be up 2, 4, 6 over 2. So 6 over 2 is 3. So for the red line, it's shaded above the red line, so that's greater than, and it's a solid line, so it's greater than or equal to 3x plus 2. And then the blue, let's see here, our slope and our y-intercept. The y-intercept is -2. And the slope, let's see here, we go up 2 over 2, up 2 over 2. So 2 over 2 is 1. So y, it is everything below the blue line is shaded, so it's less than or equal to. It's a solid line, so it has to be equal to. And then x minus 2. And that's the answer for A. For part B, I'll just start with our blue since I'm here. It looks like it's crossing. Let's see here. These are counting by 2, 4, counting by 2's again, so the y-intercept is -4. The slope, let's see here, it goes up 2, right 4, so 2 over 4 is 1/2. So we're going to have y. It's shaded down, so that's less than, and it's a solid line, so it's less than or equal to 1/2 x minus 4. The red line, its slope and y-intercept, let's see here, the y-intercept is 0, and the slope looks like it goes down 2, 4, right 2. So -2 or -4 over 2 equals -2. So it will be y, and it's shaded everything above the dash line. So that's greater than and only greater than, because it's not a solid line. So y is greater than -2x plus 0. So it's just y is greater than -2x, and y is less than or equal to 1/2 x minus 4. All right, our last example of the day, or last two examples, I should say. Example 3, they are using a system and applying it to a real-life situation. So, Malia has $500 to purchase water bottles and a pair of socks for a fundraiser for her school's cross-country team. She needs to buy a total of 200 items without buying too many of just one item. What graph shows the possible numbers of water bottles and pairs of socks that Malia should buy? So I'm going to let my water bottles be X and my socks be Y. And let's see here, it says we have to buy 200 items total, at least 200 items. So we can buy more. So X, all the water bottles plus all the pairs of socks have to be greater than or equal to 200. And then we have $500 to purchase. So we can't go over the $500. That's all the money we have. So let's see here. The water bottles are $2 per water bottle. So 2x plus the socks are $3 a pair. They have to be less than or equal to 500. And basically you just graph this inequality. So let's see here. Let's count by, let's just go by 50s. Let's see here. So we can go 50, 100, 150, 200, 250, 300, and then up and down. Let's see here. This was our x's. These are our y's. We'll just go by 50 as well. So 50, 100, 150, 200, 250, 300, 350, 400. We may not have to go that high, but it's okay if we do. And remember, these are just sketches, so we're just sketching a graph to see what would help us. All right. So again, you can solve these for y. I don't really like doing that. I like finding the x and y intercept for both equations. So this top one, I'll do it first. X and y. If the x-intercept, to get the x-intercept, you let y be 0. So if y is 0, then x has to be 200. And to get the y-intercept, you let x be 0. And if x is 0, then y is 200. So the x plus y is greater than or equal to 200. The intercepts are 200. So I want to see here. We'll go 200 there and 200 there. And we have a solid line connecting those. And we're going to shade it's greater than, so we'll shade above that line. So everything above that line is fair game for buying. That's the number of items we can buy. Okay, so I'm going to let this one be a blue line. So let's see here, x and y. If I don't sell any water bottles, so 0 for x, and I only buy y, so that would be 500 divided by 3. So that would be 166.6 repeating. And if I let the y's be 0, so I don't buy any socks, how much money would that be? Let's see here. That's 500 divided by 2 is 250. And so let's craft these. Let's see here. 0, 166. So it's about right. I don't know, about right there. And then 250, 0 is right there. Again, we cross our line right there. And we shade below on this one because it's less than or equal. So everything below the blue line, just like that. And as you can see, we don't have a very big chunk where the graphs cross, but they do cross. Okay, so it's that little green sliver, little triangle right there is my answer. Those will show how many of each we can buy. And our last example uses this graph. As you can tell, this graph's a lot more prettier than mine. I know more prettier is not correct English, but I teach math, so please forgive me. So it says, let X represent the number of water bottles and Y represent the number of pairs of socks that Malia buys. Use the graph to determine if Malia can buy 75 water bottles and 100 pair of socks. So basically all we have to do is figure out is 75 and 100 in the double shaded area. So 75 would be, let's see here, almost to 80, and 100 would be, well, about right there. So that is definitely no. That is not going to be a point where it's in the double shaded area. So this red area that I'm drawing right here is where the point would have needed to be. So I hope this quick little examples of how to do systems of inequality helps. Y'all have a great evening or a great day, and as always, stay above the line.